Hello everyone, let's talk about cost function, also known as loss function. Think of a cost function like a judge, which basically judge or measures the performance of a machine learning model. Let me give you guys a simple example for guessing the number between 1 to 100. Let's take a simple analogy for this, predicting a number line by minimizing the guess error. So I drew a number line here from 1 to 100 and my goal is to reach 50. So let's start by a random guess, which is 80, and let's count how far I was from my initial goal. So subtracting 80 from 50, so the initial guess minus my goal, I get 30, which can be called as a guess error. And we take another guess of 60. So to calculate my guess error, I would subtract 60 from 50 and I get 10. Now you must be wondering, what the hell is guess error? So think of guess error as like how far were you or how wrong were you from your initial goal, which was in this case 50. So let's come back to our first guess. We were wrong by 30, and in our second guess we were wrong by 10. So the smaller the number, the more better you are getting, and you can say the lower the cause, which is error, the better and accurate your model will be. Now I use this example to give you an overview of how cost function works. And to sum up the cost function, it basically measures the error in the model's prediction or the guess. And to get the correct answer, you have to subtract the model prediction from your actual value. So understanding the guess error is easy. If we take an example from the number line from 1 to 100, my guess was 60, the second guess. And if I calculate how far I was from my initial goal, which is 50, so I was far by 10, and I calculated this by subtracting 60 from 50. So it says basically I was 10 steps ahead from 50, which was my goal. Now let's talk about math behind this concept. So we're gonna take mean squared error, which is the most common cost function and widely used in industries. Now I'm gonna divide finding the mean square error in 3 simple steps by taking an example of predicting house prices. And if I take my actual house price to be $300,000 and assign it to a value of y, and my model predicted value, which is $250,000, and I'm gonna assign it to h. So my step 1 will be finding the error, and to find the error you subtract the actual price with the model predicted price. So in this example it will be 300k minus 250k, and I would get $50,000. But what if my error is in negative, like negative 50k? Now it would create a huge mess since minus cancels out positives. Now you must be wondering, what's the solution? So it's basically step 2. So we square the error. For example, we square the 50k, which will be 2500, and if we square the negative 50k, we will also get the 2500 positive value. Now we move on to our step 3, which is finding the average or mean. Now why do we do this? It's because our model learns from 1000 house prices, not just one. That's why we sum up the squared error for each house and we take the average. Now I hope you understood those steps, and we can move on to our mean square error equation. Let me tell you the elements real quick. So the J stands for cost function or the final cost name, and the M stands for the number of samples, or in our example the number of houses. And this symbol you see is basically a fancy symbol of saying add them all up, and the yi minus the hi, the whole square, is basically calculating the squared error for each house. So to give you an example of mean square error equation with house price prediction example, is we calculate for all the houses m, we calculate the square error and add them all up, and then divide the number of houses to get the average error, all by using this MSE equation. So by now I think you should pretty much get the idea behind the MSE equation And if you want a full working example of this, you can write in comment section below. Then I'll soon make a video for this. Okay, let's move on to the use cases, the real world use cases for the cost function. So first example would be the predicting prices like we took for the house. It can be anything for like stock or flight prices, which basically measures the prediction error in monetary terms. And what this does is like tell how many dollars the prediction was off. Second would be weather forecasting, which is measuring the temperature error in degrees and showing how inaccurate a temperature prediction was. Then third would be self-driving cars, which measures the car's distance from the center of the lane to guide the steering corrections. Another example would be checking if the email is spam or not, or is this a picture of cat or dog, which will use cross entropy, which is a perfect example for classification problems. Now to conclude this video, I'm going to talk about what we did. So first, the cost function, which scores how bad a model predictions are. Then our model main goal, which is to minimize the cost. So the lower the cost, the better the model. And last thing would be why our cost function is important for learning, as it guides the learning process by telling an algorithm like gradient descent how to adjust the model to become more accurate. And hopefully I'm going to talk about gradient descent in next video. Okay, then that's a wrap up. If you have any doubts, any kind of doubt, then you are free to write down in comment section below. And make sure to drop a like for some motivation and share this video among your friends. Thank you so much.